Beneath the streets of one of the world's most powerful cities lies an engineering marvel that most Londoners will never see. Every time rain hammers down on the capital, millions of tons of sewage and stormwater flow through a maze of tunnels so vast, so deep, that they dwarf the London Underground itself. This is the story of how Victorian ambition, modern catastrophe, and cutting-edge engineering combined to create a hidden world protecting 9 million people from drowning in their own waste. The problem that wouldn't wash away. London has been fighting water for centuries. In 1928, the Thames burst through its embankments, flooding central London and drowning 14 people in their basement apartments. 25 years later, in 1953, disaster struck again. A massive storm surge roared down from the North Sea, killing 307 people across eastern England. In London's East End, water rose nearly 3 meters, flooding thousands of homes in Canning Town, West Ham, and Plumstead. Families were evacuated in the middle of the night, wading through chest-deep water as rats poured from the sewers. But London's water problems run deeper than storm surges. The city's sewerage system was built by Joseph Bazalgette in the 1860s, designed for a population of 4 million. Today, over 9 million people live in Greater London. The Victorian sewers simply cannot cope. Every time it rains, even a light drizzle of just 2 millimeters, raw sewage overflows directly into the Thames. Before the latest upgrades, this happened more than 60 times per year, dumping millions of tons of human waste into the river that flows through the heart of the capital. The environmental impact is devastating. When sewage enters the river, bacteria consume the oxygen in the water, suffocating fish and destroying ecosystems. The Thames, once declared biologically dead in the 1950s, had been slowly recovering. But the constant sewage discharges threaten to reverse decades of environmental progress. The Thames Barrier. First line of defense. The 1953 flood finally convinced authorities that London needed serious flood defenses. The result was the Thames Barrier, one of the most ambitious engineering projects of the 20th century. Spanning 520 meters across the river at Woolwich in East London, this movable barrier became operational in 1982. It consists of 10 massive steel gates, each weighing 3,300 tons and standing as tall as a 5-story building when raised. The barrier works by closing during high tide to prevent storm surges from the North Sea flooding the city. When a surge is predicted, typically with up to 36 hours notice from weather satellites and monitoring stations, the gates rotate upward from the riverbed. The process takes about 90 minutes. Once the danger passes and downstream water levels drop, the gates lower and the Thames flows naturally again toward the sea. The barrier protects 125 square kilometers of central London, including the Houses of Parliament, Buckingham Palace, and countless homes and businesses. Since opening, the Thames Barrier has been deployed over 220 times. During the winter of 2013 to 2014, it closed a record 50 times in just 13 weeks, preventing catastrophic flooding during the highest tides seen since the barrier's construction. Without it, water would have inundated the London Underground, disabled 8 power stations, flooded 16 hospitals and 400 schools, and damaged 500,000 properties. But the Thames Barrier only solves half the problem. It protects against tidal flooding from the sea, but it does nothing about the sewage crisis beneath London's streets. The super sewer solution. By 2011, London's sewage situation had reached a crisis point. The Victorian combined sewer system, which handles both sewage and rainwater together, was failing. As the city expanded, developers paved over green spaces with concrete and tarmac, creating impermeable surfaces that prevented rainwater from soaking into the ground. Instead, millions of gallons of rainwater rushed into the already overwhelmed sewers. The solution required thinking big. Engineers proposed the Thames Tideway Tunnel, a deep-level sewer running 25 kilometers from Acton in West London to Abbey Mills in the east, following the route of the Thames. This would be the largest infrastructure project ever undertaken by the UK water industry. With a price tag of £4.5 billion, the tunnel's statistics are staggering. It runs up to 67 meters deep, deeper than most underground lines. Its diameter measures 7.2 meters, wide enough to fit 3 London buses side by side. The tunnel would connect to 21 of the most polluting overflow points along the Thames, intercepting sewage that currently spills into the river and diverting it to treatment facilities. Drilling through history, construction began in 2016 and immediately presented extraordinary challenges. London sits on layers of chalk and clay formed millions of years ago. Beneath the modern city lies a geological time capsule, with ancient river channels, wartime bomb shelters, Roman ruins, and countless utility pipes and cables. Drilling a tunnel this size required navigating through all of it without destroying critical infrastructure or historical artifacts. Engineers deployed 6 tunnel boring machines, massive mechanical worms that eat through rock. Each TBM weighed 1,350 tons and stretched 147 meters long, equivalent to 12.5 double-decker buses lined up end to end. The machines had to be lowered into the ground through massive vertical shafts, some as wide as the dome of St. Paul's Cathedral and up to 60 meters deep. The tunneling phase alone excavated 3.48 million tons of spoil. Rather than clogging London's roads with 344,000 heavy goods vehicles, engineers transported the material by barge along the Thames, saving 24,400 tons of carbon dioxide emissions. All 6 TBMs completed their drives in 2022, marking the end of the most technically demanding phase of the project. The TBMs were named after inspirational women connected to the local areas they passed through. Rachel honored engineer Rachel Parsons, who founded Britain's first women-only engineering company. Selina commemorated Dr. Selina Fox, who established the Bermondsey Medical Mission in 1904, providing healthcare to London's poorest communities. The Lee Tunnel connection. The Thames Tideway Tunnel doesn't work alone. It connects with the Lee Tunnel, a separate project completed in 2016. Running 6.9 kilometers from Abbey Mills to Beckton Sewage Treatment Works, the Lee Tunnel intercepts the largest combined sewer overflow in London. This tunnel alone captures 5 million tons of sewage annually that would otherwise pour into the River Lee and Thames. Together, these tunnels form the London Tideway Tunnel System, with a combined capacity of 1.6 million cubic meters. When heavy rain hits London, sewage flows into the interconnected tunnel network rather than overflowing into the river. The sewage is stored underground until it can be pumped to Beckton, one of Europe's largest treatment facilities, where it undergoes processing before safe discharge. In May 2024, the Thames Tideway Tunnel was physically connected to the Lee Tunnel, completing the full network. Testing began immediately. During a single rainy day in November 2024, the system captured 848,365 tons of storm sewage that would have otherwise polluted the Thames. The tunnel was progressively brought online throughout late 2024 and early 2025, with connections made at landmark locations, including Putney Embankment, Chelsea and Victoria Embankments, Blackfriars Bridge, and King Edward Memorial Park in Wapping. A river reborn, the environmental benefits are already visible. Since the Lee Tunnel became operational, water quality monitoring has detected 14 species of fish in the Channelsea River, an indicator of a healthy urban river ecosystem. With the full system now operational as of February 2025, the number of sewage overflows into the Thames is expected to drop from 60 per year to fewer than 5, reducing pollution by 95%. For the first time in 150 years, the Thames can truly recover. The tunnel system means that only during the most extreme weather events, roughly equivalent to 3 days of continuous heavy rain, will any overflow occur. For London's wildlife, from herons hunting along the riverbanks to the increasingly common seals swimming in the tideway, this represents a lifeline. The project also created unexpected benefits for Londoners. Construction sites have been transformed into 1.2 hectares of new public space, including riverside parks at Blackfriars and Victorian Embankment. Some areas feature deliberately floodable foreshores, allowing people to safely explore the river's edge at low tide and understand the Thames's natural rhythms. Public art installations commemorate the project's impact, including bronze sculptures shaped like sandbags that serve as informal seating on the Albert Embankment. The future of flood defense. London's flood defense network represents a model for cities worldwide, grappling with aging infrastructure and climate change. But the work never stops. The Thames Barrier, now over 40 years old, was originally designed to operate until 2030. Climate change is accelerating sea level rise and increasing the frequency of severe storms. By the 2080s, climate scientists predict that London winters will be 30% wetter, with heavy rainfall events occurring twice as frequently. The Thames Estuary 2100 plan looks ahead to these challenges, proposing adaptive measures including potential new barriers further downstream and sustainable urban drainage systems throughout the city. These systems would include more permeable pavements, green roofs, and parks designed to absorb rainwater rather than shunting it into sewers. Engineering solutions alone cannot solve London's water challenges. The city continues to grow, with developers pressured to build on the Thames floodplain. Every new building, every paved surface, every expansion of the urban footprint adds stress to the system. The key lies in working with water rather than constantly fighting against it, accepting that London's relationship with the Thames must evolve as the climate changes. The hidden tunnels beneath London represent more than impressive engineering. They demonstrate what's possible when cities commit to long-term infrastructure investment and environmental restoration. If you found this story fascinating, make sure to subscribe for more deep dives into the world's most ambitious mega projects. Hit that notification bell so you don't miss our next exploration of the hidden systems that keep modern civilization running. And let us know in the comments, what other invisible infrastructure projects should we investigate next?